Hello, welcome to my lecture on truth functions. In this section of our course, namely the section on propositional logic, we're going to learn how to construct truth tables. But why would we do this? Well, it's because it's a method for determining whether or not a given argument is valid. In order to understand truth tables, we need to understand truth functional propositions, that is, statements. Again, why? Because truth tables analyze the possible truth values of truth functional propositions. That is, truth tables give the various ways that propositions or statements can turn out true or false. So what is a truth value? This concerns whether a statement is true or false. So Obama is president. Possibly that's true, possibly that's false. Those are the two possibilities for its truth value. And if it's true, we can denote that with the capital letter T. If it's false, we can denote that with the capital letter F. As it turns out, it's false that Obama is president. If the truth value of a compound proposition is determined by the truth value of its component statements and the logical operators involved, the compound is said to be truth functional. What does that mean? It means that when you're dealing with a statement, compound proposition, and you have a logical operator, for example, and a statement. So it's not the case that Obama is president. It's not the case that would be our logical operator. Obama is president would be our statement. If the statement, it is not the case that Obama is president, is truth functional, then what that means is that the truth value of the entire statement is solely determined by the truth value of the statement. It is not the case, the phrase, it is not the case that in the statement, Obama is president. So the truth value is determined exclusively by the logical operator and the truth value of this component statement. So if Obama is president is true, then it is not the case that Obama is president will be false. A connective is truth functional if and only if the truth values of the component statements the connective joins always completely determine the truth value of the compound statement formed by the connective. So think about the statement, it is not the case that Obama is president. That connective, it is not the case that, is truth functional. The connective is truth functional. That's because, given the nature of the connective and the truth value of the statement Obama is president, you can determine the truth value of the compound statement formed by the connective. So given the nature of the phrase, it is not the case that, and say Obama is president is true, so given the nature of the connective plus the truth value of the statement Obama is president, we can determine the truth value of the entire statement. So when Obama is president is true, the entire statement is false. So the connective is said to be truth functional. As I said, the connective not is truth functional. Obama is not president. Here we can display it in a sort of truth table. Take the statement Obama is president and put it in the top left of the table. Take the statement Obama is not president and put it in the top right. What you have here is the component statement Obama is president, and it's modified in the top right by the connective not. In the bottom left, you have all the possible truth values for the statement Obama is president. It can either be true or it can be false. Regarding the connective not, whenever the statement that it negates is true, the entire statement will be false. Whenever the statement it negates is false, the entire statement will be true, as you can see. When Obama is president is true, you see on the bottom left the letter T. Then go to the bottom right in the top row. It turns out that Obama is not president is false. So whenever Obama is president is true, Obama is not president is false. Whenever Obama is president is false, Obama is not president is true. The connective not is truth functional because the truth value of the entire statement is determined by the truth value of the component statement plus the nature of the logical operator not. Certain connectives are not truth functional. Believes is not truth functional. Jerry believes that Obama is president. We can't determine the truth value of the entire statement simply by knowing the truth value of the statement Obama is president. So if you can see on this chart, or this table, whenever Obama is president is true, it's up in the air whether or not Jerry believes that Obama is president. And whenever the statement Obama is president is false, it's still up in the air whether or not Jerry believes that Obama is president. So simply by knowing the truth value of the statement Obama is president and the nature of the word believes, we cannot determine the truth value of the entire statement. So believes is not truth functional. The same goes for hopes. Jerry hopes that Obama is president. Simply by knowing the truth value of the statement Obama is president, you cannot determine the truth value of the entire statement Jerry hopes that Obama is president. Because, look, even if Obama is president, Jerry might hope that he is or hope that he isn't. And even if Obama is not president, Jerry might hope that he is or hope that he isn't. The same goes for belief. So we say that hopes is not truth functional. The truth value of the entire statement is not determined exclusively by the nature of the word hopes and the truth value of the component statement. Let's see how well you understand this. Here are a few practice questions. I judge that you are wrong about Susie. The preceding statement is truth functional, true or false? False. Consider the following table. In the top left, we have the component statement, you are wrong about Susie. In the top right, we have the compound statement, I judge that you are wrong about Susie. Simply because you know the truth value of the statement, you are wrong about Susie, that doesn't mean you can determine the truth value of the statement, I judge that you are wrong about Susie. So whenever you are wrong about Susie is true, it's up in the air, whether it's true or false, that I judge that you are wrong about Susie. Whenever the statement you are wrong about Susie is false, it's still up in the air. The truth value of the statement, I judge that you are wrong about Susie. How about this one? It is not the case that you will go to the store. The preceding sentence is truth functional, true or false? True. Consider the following table. When you will go to the store is true, the statement, it is not the case that you will go to the store, is false. When you will go to the store is false, the statement, it is not the case that you will go to the store, is true. So, the truth value of the entire statement, it is not the case that you will go to the store, is determined by the nature of the phrase, it is not the case that, plus the truth value of the claim, you will go to the store. So, the phrase, it is not the case that, is truth functional. Note that each of our logical connectives that we're dealing with in propositional logic are truth functional. Negation, conjunction, disjunction, conditional, and biconditional. The truth value of the compound statements made up by these connectives depend solely on the truth values of their component statements plus the nature of the connectives.